Okay, great. So it looks like everyone is in on time and quiet, which if you're going to come here won't continue, I can tell you that. Usually I'll spend at least 5 minutes trying to get everyone to be quiet. But yeah, thank you everyone for coming this morning, especially to the early session. It's really good to see it so full already. You guys are the really keen ones. So my name is Andrew McDaid. I'm a senior lecturer here in Mechatronics Engineering. And my job today is just to give you an introduction into what Mechatronics Engineering is. But before we start, I just was interested about where everyone's from. So maybe, can you raise your hands if you're from Auckland? Okay, so that's most people. What about north of Auckland? Okay, that's cool, quite a few keen to come down. Anyone from south, Hamilton? Good, further south, Wellington area? Oh, nice. South Island? Good, a few over there. Yep. International, anyone? Yep, awesome. Okay, so that's cool. So that's really good to see everyone. Thank you all for coming. Hopefully you can get a lot of help today and a lot of insight into what we can offer here at the university. So, as I said, what I'm going to try and do today is just to give you an overview about Mechatronics Engineering. I'll also give some examples of mechatronic systems to hopefully give you some idea about how these systems operate in the real world, and then talk about mechatronics here specifically at the university, and finish with some career prospects. So mechatronics might be a new term to some people. So what it is the combination or the synergy of mechanical engineering and also electronics. So mechanical is the part associated with machines, mechanisms, so essentially things that move. And electronics is the science and technology of electronic devices. And mechatronics, as I say, is the integration of these things and also the combination of those with computer technology and control systems. So this here is a diagram which sort of summarizes a little bit what mechatronics engineering is. As I said, it's the combination of the mechanical, electronics, controls, and computers. So inside this circle here, you have the sort of fundamental core technologies that mechatronics is based on, and what you will learn. And then around the outside, we have some of the application areas that mechatronics is then applied to. So things like manufacturing, consumer products, medical devices, aerospace, and automotive engineering. And what's also really important about mechatronics is this idea of, and engineering in general actually, is the idea of the more sort of soft skills, so design, creativity. Teamwork is a very big part, especially in mechatronics, because you are working across disciplines. Often you'll be working with people that are more specialized, specifically in mechanical or electronics, so you could be interfacing across different teams. This also means that mechatronics engineers often go into leadership and into management positions as well, because you have a more sort of systems engineering approach. So we teach a lot of these things, and also other sort of professional development type skills. So a typical mechatronics system would be made up of the mechanical system or structure of the body of the device. We have also sensors. So sensors are what helps the system understand what's going on in the environment. So it could be optical or vision-based sensing. It could be temperature. It could be speed. It could be whatever we want to know about what's going on. We then have the actuators, which is what performs the action. So that is typically electric motors. It could be hydraulics. It could be pneumatics, which then can perform the action. And then the control system is really the brain. So that's what takes the information from the sensors, makes some decision, and then decides what action to perform based on those decisions. And then we have other sort of peripherals, which is memory, networking, communication, Bluetooth, Wi-Fi, that sort of thing. So this is just a list of different devices that would be considered mechatronics devices. I think more and more so now, things that weren't traditionally mechatronics devices are becoming more intelligent. Obviously, the automotive industry over the past, more than 100 years has shown that development, where now there is all the modern cars are moving towards self-driving. They have a lot of intelligence in them, but even more in the home as well. So you see the ads on TV with air conditioning units that you can control with Wi-Fi. You can have kettles, all sorts of different devices are all interfacing with Internet of Things, and they're all encompassed by Mechatronic systems. So as I sort of touched on before, a good example of this is Google's autonomous vehicle. They're moving towards completely driverless. They first of all started with modifying Toyota Prius, and now they've moved on to this design over here, which is a complete redesign of a vehicle specifically to be driverless. And as I say, it consists of a whole host of different sensors. So there's radar sensing, there's laser sensing, video sensing, and this is really to provide redundancy and to use different sensor modes for picking up different things. So there's a lot of information and data that the car is processing. Of course, it has actuators. It has to be able to drive. It has to be able to turn and move around. And then the control system as well, so how it makes decisions on what to do. And that's all implemented in the software. So this is a really good example of how technology is moving more towards mechatronics and intelligent systems. And you can imagine in the development of a product or a system like this, there's a large team and there's a lot of different specialties, and in mechatronics you sort of have the ability to be able to work across all those different parts. So I'm going to show an example of how we teach this to students. So in the first year of engineering is a general across all engineering, then you specialise. If you specialise in mechatronics, the second and third year then we teach you more about the fundamentals, so the fundamentals about mechanical and electronic systems. And then the final year we do a lot of design and systems integration. So this project is an example of a final year student project. They work in teams of 4, and the brief is to develop an autonomous firefighting robot that can move around a maze, avoid obstacles, and put out fire. And they have a number of criteria which they're then judged against. So this here is an example of this, and the students have designed all of this, the mechanical, electronics, everything from scratch. So that was one design. This here's another team's design. And as I sort of mentioned before, we also teach a lot of other sort of professional skills. So we teach them how to present their projects. So they just had to design websites as well and do some sort of marketing type activities as well. So this here's an example of another design, another approach that was taken. So and just sort of showing how they've tackled the problem. And you can see it's quite a different solution. Okay, so that's so another area in which our mechatronics students work is across Formula SAE. So this is a fully student-led competition. So the students themselves can be involved throughout their degree, and it's an Australasian competition, and the students again design everything from scratch, from mechanical design through to electronics, and obviously being the driver. Okay, so the mechatronics parts of this project, well, as of 2 years ago, the University of Auckland team has switched across to fully electric vehicle now. So they've decided to make the move because they can get better, potentially better performance, better accelerations, better control over all the individual wheels. So there's becoming a more and more mechatronics element to this team. But there's a number of different electronic systems that we develop, from gear shifters through to touch screens, shock absorbers, and then also there's a huge amount of data that the students collect on the car itself. So a lot of sensors and analysis to be done to optimize the performance of the car. Another thing I guess we're very proud of in New Zealand is the America's Cup. We have students that have gone on to work with the America's Cup team. Again, this is an example of a mechanical and mechatronic system. Obviously, there's a huge amount of mechanical design, aerodynamics, there's carbon fiber design. But nowadays, there's also, if you watch the last America's Cup or follow the racing going on, there's a huge amount of data, a huge amount of control systems and automation that's also coming into the sailing. So that's going to be an interesting one to watch as well when the next challenge comes up. Industrial automation is, of course, a more, I guess, a more traditional area of mechatronics. It's been around for a long time. So robots operating in production lines, automating manufacturing. More and more so now, the robotics are coming outside of factories and more interacting with humans. So this sort of example of an industrial robot where it's more about cooperation with humans and being flexible and adaptable to different tasks. So not so rigid and not so sort of pre-programmed, which is sort of some of the directions of industrial automation. In our department, we also have quite a big emphasis on medical robotics as well, which is the area that I work in, or biomechatronics. So this here is the application of, again, the mechatronics, the core engineering that you learn, but to medical applications. So this here is an example of some of the assistive devices that we've developed. So exoskeletons, robotics that are worn by humans. Maybe someone has an injury, or they have a disability, or else it can be used for sort of, again, manufacturing and production lines. So these here, as I said, an elbow exoskeleton, we integrate them with games, and we also, so to help people perform their rehab. This here are some lower limb devices. We have gait trainers for overground rehabilitation. We also have treadmill-based robots. We have a fully kitted out motion capture analysis laboratory as well, which we can analyze a lot of the systems. And we also do brain-computer interface as well, so we collect the electrical signals from the brain and use them to drive some of the robots that we have. Another example we're looking at is robotic human organs. So there's a lot of potential applications for chewing robots, for digestive robots, to simulate human organs and to be able to help come out with better therapies. can't really talk about mechatronics without drones, which is another one of the areas which everyone is very interested in. A lot of our research is focused on drones and aerial manipulation in the forestry and farming industry, which is quite important, obviously, for New Zealand. So things like sampling the pine trees in the forest to see what sort of state are they ready for harvesting, for pasture analysis. So that's sort of the area that we're looking at for drones. And if you haven't already, you can go for a tour, and there are some of those things on display out in the foyer on level 3. Okay, so coming back to the degree program itself. So what we offer is degrees in mechanical specialization and mechatronics. So those are across bachelor's level, master's, and through to PhD. We also have a Masters of Engineering Studies, which is a combination of some taught papers and some research, specifically on medical devices and technologies. And really, the mechatronics, what is, I guess, unique is that it's very multidisciplinary rather than very specialized. So, of course, there are, the mechanical is more focused on the mechanical side of things. You can also do electrical engineering or software engineering. And the difference really is with mechatronics is that you're looking more at a systems level approach. So then, of course, teamwork, leadership, and interaction with other engineers is very important. So career prospects for mechatronics engineers are very strong. We have every year, sort of around April, May, we have a lot of companies come in and talk to the students and try and convince them all to come work for their companies. Most of our final year students will have jobs now already, or else be accepting jobs for starting in 2019 when they graduate. So we have really good relationships with a lot of the employers in New Zealand, and they're very keen on our graduates. They often comment on the problem-solving ability, and again, the sort of the higher level systems approach that our mechatronics engineers have and bring into the companies. And as I've sort of touched on a few times, mechatronics engineers tend to go into the sort of the leadership and management positions because they have that high level overview. So the list of employees, obviously not exhaustive, but there are the big ones. Fisher & Paykel Healthcare are probably one of the biggest employers of mechatronics engineers, as well as consultancy companies, Becker. Our students have also gone on to financial industry, places like Boston Consulting, Price Waterhouse, and all the way through to startups as well, so Soul Machines, StretchSense. A lot of our graduates are either the founders of those companies or else employees in those companies. And also, if you're interested in going on to postgraduate study, either at this university or overseas, we have a lot of students that also go on to those opportunities. So I've had students going on to get scholarships to study at Cambridge University in the UK, as well as a number of US universities with Fulbright scholarships. So getting an undergraduate degree here definitely keeps pathways open to international postgraduate study as well. So in summary, mechatronics engineering offers excellent challenges and opportunities in a wide range of fields, so you're not sort of boxing yourself, you're not becoming very niche, you have a wide range of areas you could get into. You really look at things from a high level, the whole technology problem, and really you're giving yourself the opportunity to solve some of the major challenges which we see around things like healthcare, global warming, renewable energy. These are all sort of the big problems which we need more engineers to be coming up with solutions for. And of course you have excellent long-term employment prospects as well. So I'm just going to play a video to finish off, which is from some of our colleagues, which just sort of again goes over and summarizes mechanical engineering and mechatronics.
If you enjoy science and are fascinated by how things work, you've got great analytical and creative problem-solving skills and strong maths, but yet you really like to do practical tasks, then a mechanical or mechatronics degree is the one for you. Mechanical engineers don't just design and figure out how to build machines, they design planes, cars, robots, smart devices, digital cameras, satellite dishes, even super yachts. Mechatronics engineers are the ones who integrate these machines with computers. You'll find these degrees open up a wide range of career possibilities you might never have thought of before.
Such as using our can-do attitude and Kiwi ingenuity to develop world-class automation, robotics and vision systems, like we do here at Can-Do Innovation.
Or developing designs for large-scale manufacturing,
like we're doing here.
And we went on to design the world's most advanced plasma cutting machines here in New Zealand.
These are universal degrees that will allow you to work anywhere, in industry, commerce or academia.
For the past 3 years, I was seconded to BMW in Germany for the I project, and in that I was working in the department responsible for the manufacturing of carbon fibre reinforced plastics, which make the majority of the structure of this car.
Mechatronics is a blend of mechanical, electronic and computer systems engineering. This involves designing and controlling things like surgical robots, wearable exoskeletons and self-driving cars, as well as automating large-scale industrial machinery, systems and production processes.
Our programs are led by a team of passionate and research-active academics. Each year we welcome around 200 undergraduate students, starting their specialisations in mechanical engineering and mechatronics engineering. Our labs house some of the latest engineering technology, such as laser scanners, 3D printers, medical robots, computer-controlled manufacturing systems,
And here, motion capture for unmanned aerial vehicles.
Plus, there's our twisted flow wind tunnel and our new closed circuit wind tunnel, which is the largest in New Zealand. These wind tunnels can be used for building, sail and vehicle aerodynamics, wind energy and elite cyclist studies.
You'll have opportunities to participate in a wide range of activities outside the lecture room. One example is the Formula SAE team, who design, build and race a new car each year. Last year they came third in the Australasian competition. We offer 2 world-class, internationally respected programs that will give you a firm foundation for your future career, and will give you the opportunity to tailor your final year to match your own interests and career objectives. The opportunities are endless. Don't miss out. Achieve the amazing.
Okay. So that's it from myself. I'm happy to take any questions now. I think we have a few minutes, or else if not, you can always come and talk to me after, or there's also a lot of displays and subject experts through on level 3 as well, so I recommend you go and visit them. So thank you very much.